All right, last time we talked about prime factorization. I'm going to show you now how you can use that to find what's called the greatest common factor. And this is going to be helpful when we start simplifying fractions if you don't know how to do that already. So what is the greatest common factor? Well, let's break it down into the three words. So factors are numbers that are being multiplied together. Common just means what's shared between a set of data. And then greatest just means the largest. So if, for example, we have, let's say, 4 and 8, and I want to find the greatest common factor, well, I want to find what's the largest number that I can multiply by another whole number to get 4 and 8. So these are smaller numbers, so we can write out all their factors. For 4, we'll have 1 times 4. Those are factors, and then 2 times 2. So there are 3 distinct factors of 4. For 8, we have 1 times 8, and then 2 times 4. Actually, I'll do like that to show this 2 times 2 is 4. And then we want to figure out, compare the lists. Which number do they have in common, and then which is the greatest of those numbers? So they both have a 1, they both have a 2, and they both have a 4 as factors. So since 4 is the largest, the greatest common factor for this example is 4. So this is writing out the factors, kind of knowing your multiplication tables, which really that's the best way to go about this, but I'll show you how you can use prime factorization in this next example as well. Here we're finding the greatest common factor of 16 and 40. So let's do it the prime factorization way. So we'll start with 16 and let's prime factorize it. If you don't know how to do that, go back and watch the last video. I see that 16 is an even number, so I know that 2 is a factor, and it's going to be 2 times 8 is 16. I can't break down 2 any further because that's a prime number. So I'll look at this 8. Well, 8 is also even, so I can, I know that 2 is a factor. Can't break down that 2 since it's prime. And then 4, I can break that down into 2 times 2. So 16, I can write this as 2 times 2 times 2 times 2. If I look at, let's go here with 40. Do that part later. So 40, if we break it down, that's an even number. So 2 times 20 is 40. 2 is a prime number, so I'll circle it. And then 20, also an even number, so 2 times 10 is 20. I can break down the 10 some more to 2 times 5, and then both of those are prime numbers. So 40's prime factorization is 2 times 2 times 2 times 5. So let's look at these and figure out what the greatest common factor is. Well, they each have a 2, they each have another 2, and they each have another 2. And then the 5 and the 2 are the ones not in common. So there are 3 2's in each of their prime factorizations that are common. So that's what our greatest common factor is going to be. Our greatest common factor is going to be 2 times 2 times 2, or in other words, 8. Let me show you how to do it kind of the first way that we did it in the video, just to prove that the answer is 8. So let me just take 16 and I'll list out its factors. Well, obviously we got 1 times 16, and then 2 times 8, and then 4 times 4. So I'll just put 4 by itself there like that. So those are my factors of 16. And then for 40, well, I got 1 and 40. Those multiply together to make 40. 2 and 20. Those multiply together to make 40. 3 is not a factor of 40, but 4 definitely is. 4 times 10. And then 5, yep, that can go in. 5 times 8. And then 6 is not a factor. So I think that's everything. And then we look and see which ones they have in common. Well, one is they have 1 in common, they have 2 in common, they have 4 in common, and they have 8 in common. And since 8 is the larger of the common factors, again, the greatest common factor is then therefore 8. All right, let's do this one again with prime factorization, but honestly, knowing your multiplication tables inside and out without even having to think about them, that's the best way to master greatest common factor and how you're really going to use it when you start doing things like simplifying fractions. But let's look at 33. I know that's divisible by 3. So 3 times 11. 3 is a prime number. 11 is a prime number. So that's the prime factorization of 33. And then 77, I know that that's divisible by 11. 11 times 7 is 77. Both of those are prime numbers. So we can list these out. 11 times 7 is the prime factorization of 77. And then 3 times 11 is the prime factorization of 33. The numbers they share in common are the 11s and nothing else. So that means our greatest common factor is 11 between 33 and 77. Let me show you the faster way to do this when you're given 2 numbers and finding the greatest common factor between them. Start with the smaller number and just list out all those factors. You'll have fewer factors to work with and then therefore fewer numbers to test if those are also factors of the other number. So let me show you what I mean. Factors of 4 are 1 and 4, and then 2, right? 1 times 4 is 4, 2 times 2 is also 4. Let's see if any of these numbers are factors of 100. Well, can that go into 100? Well, yeah, of course. 1 times 100 is 100, so 1 is a factor. 2, that can also go into 100. 100 is an even number, so 2 times 50 is 100, so that's a factor. That could be an answer. That could be the greatest common factor. And then 4, that can also be multiplied by 25 to get 100. So 4 is also a factor. So since all 3 of these numbers are factors of 100 and also 4, we just picked the greatest one, which is 4. So the greatest common factor is 4. So again, start with your smaller number. Like again, we had only 3 numbers to test, and whichever of those numbers is the largest and can also is also a factor of 100 in this example, or the other number, there's your answer. So when should you use prime factorization versus the trick that we just did? Well, if your numbers are kind of common numbers, as in they show up a lot or they're easy to work with, use that trick that we just did. But here, 28 is not that difficult of a number. It's a smaller number. But 92, I can't really think off the top of my head factors of 92, so I might use prime factorization for this one. So that's what we'll do. So let's take 92. I know that's an even number. So that's going to be 2 times 46 is 92. So there's our prime number. 46 is also an even number. So that's going to be 2 times 23. 2 is a prime number. 23 can't be divided down any further by anything. So that's also a prime number. So the prime factorization of 22 is 2 times 2 times 23. And then 28, that's an even number, so we'll do 2 times 14. Prime number there. 14 can be broken down into 2 times 7. We got prime numbers there, so I will write that as 2 times 2 times 7. So what do they have in common? Well, they have a 2 times 2 in common, which is 4. So our greatest common factor is 4. And let me just write these a little bit differently. So over here, 2 times 2 times 23. Well, let me write that as 4 times 23. And then over here, the 2 times 2 times 7, I'm going to write that as 4 times 7. So here again, you can a little bit more clearly see that 4 is the greatest common factor. Another way to check whether to use prime factorization or that trick, that's just what we're going to call it, is just look at your smallest number. If it's a really easy number to work with and there's not going to be a lot of factors, or the factors of it are super easy to work with, just use the trick. So 20 is an easy number to work with, so let's use that trick. Factors of 20 are 1 and 20, 2 and 10, and then 4 and 5. So, throw a comma there. Okay, what number can go into 40? Or which of these numbers are factors of 40? Well, 20 is, 10 is, 5 is, 4 is, 2 is, and 1 is. So actually all of these numbers are factors of 40. So let's look at 195. Well, what can go into 195 of our list here? Well, 1 can. 2 cannot. So that takes that out because 195 is not an even number. 4 cannot. For multiples of 4, if you add 4 over and over and over again, your last digit will be even, and we have a 5 there, so that's not going to work. 5 can, because 195 ends in a 5, so we know that that works. 10 is not, because if we keep adding 10 over and over again, or 10 times something, we know that number is going to end in a 0, and 195 does not end in a 0. And that same logic applies for 20, so that's not going to work. So we're left with 1 and 5, and 5 is the larger one, so the greatest common factor is 5. All right, when you have variables introduced and you're trying to find the greatest common factor, prime factorization is the way to go. So let's do that here. So let's just first look at when you introduce variables and you're trying to find the greatest common factor, prime factorization is the way to go. So let's split these two terms up. First like this. So 18 x squared y, I'm going to write that as 18 times x squared times y. And then let's break down 18 here. So 18 is going to be 2 times 9, and then 3 times 3. So our prime factorization, when I circle the prime numbers, is going to be 2 times 3 times 3. And then for x, right, that's just going to be x times x. I can't break that down anymore, so I'll throw those x's in there. And then y just stands by itself, so that's going to be a prime factor. So the prime factorization of 18x squared y is this, 2 times 3 times 3 times x times y. For 36x squared, or xy squared, I'm going to write it first the same way that I did with the 18 term. So we'll do 36 times x times y squared. And then let's prime factorize 36. I know it's an even number, so 2 times 18 is 36. There's a prime number. 18 is even, so it's going to be 2 times 9. We can break that down that way. And then the 9 breaks down into 3 times 3. So we'll have 2 times 2 times 3 times 3. The x stands by itself. It cannot be broken down any further. And then y squared, well, we know that's just another way of saying y times y. So we'll have times y times y. So there is our prime factorization of 36x y squared. So let's see what they have in common. I have a 2 in common. We got 3's in common. And then, oops, I forgot to add that x over here. Forgot to add that. they do have an x in common, and they have one y in common. So we multiply all of the circled prime factors here. So our greatest common factor is going to be 2 times 3 times 3 times x times y, which is equal to 2 times 3 is 6 times 3 is 18, and then times x times y, or just xy. We can write it like that. So greatest common factor is 18xy.